Okay guys, today we're looking at 13.3. Really we're making a couple of changes because we want to be able to use this circle more. Major ideas that we're changing is instead of talking about the opposite side of theta, we're going to be talking about the y value, and instead of talking about the adjacent side, we're going to be talking about the x value. So if I look at this angle this triangle right here, from theta's perspective, the hypotenuse, h, is actually the same as the radius of the circle. So we're going to change h into r throughout the day today. We're also going to notice that this opposite side is the same thing as the y value for this ordered pair right here. It's that y value. So we're going to say that opposite side is y, and the adjacent, of course, is how far out we've gone in the x direction. So the adjacent will be x. We're going to use that idea to help us with a lot of the homework today. Alright, so we get rid of that. Let's go ahead and get started with number 8. And it says that we've got, on a coordinate plane, -6 and 9. Now I'm just going to make a really rough sketch. -6 would be over this way, +9 would be up here. So there's my point. And really we're talking about the right triangle that's made here, okay? And of course theta gets to be put in this corner right up against the origin. Well, if I wanted to, I could draw this triangle every time. But hopefully I don't need to, because I know that this is -6, this is 9, and the hypotenuse is whatever I get from Pythagorean's theorem. So I'm just going to take -6 squared, make sure it's in parentheses, plus 9 squared. That one doesn't have a negative, so it doesn't matter. And when I square both of those and add them together, I get 117. And 117 does divide by 9 13 times. So this is really, when I go to do the square root of 117, it's really going to be 9 times 13. That means I've got 3 root 13. Because the root of 9 is 3. Okay, so my radius is 3 root 13, my x is -6, and my y is 9. Okay, so when I start building my trig functions, sine of theta is now, instead of talking about a and o and h, I remember I'm using x, y, and r. It's going to be the y over the r. You can look on your book if you're confused by that, or look back at the notes we took in class. But that's going to be 9 over 3 root 13. Well, I notice right away that the 9 will reduce with the 3. And so I'm going to end up with 3 root 13 over 13. When I do the cosecant of theta, it's just going to be 3 root 13 over 9, which reduces to root 13 over 3. I continue on with the cosine of theta, which is x over r, which is going to be -6 over that 3 root 13, and this is be a 2, and that's a 1. So I will get -2 root 13 over 13. Pretty good so far. Small change has just been in the relabeling of these so that I didn't have to draw this triangle, because all this can be done without thinking about that triangle. Okay? So as we keep going, we're going to do the secant theta, which equals -3 root 13 over 6, which simplifies to -root 13 over 2. I know that the negative came from the 6, but I really don't want to write it in the denominator. I'd like to have it in the numerator, and so I do that by just peeling it up, and basically it's the same as multiplying top and bottom by a -1. The signs just switch. Last two would be the tangent of theta equal to y over x, which is the y value is 9, and the x value is negative 6, so 9 over negative 6, which reduces to negative 3 over 2. And so the cotangent of theta is going to be negative 2 over 3. And I'm done. Same idea, we're just changing lettering. Okay, don't let that get you confused. On number 15, we're actually going to use the unit circle to find 7 pi over 2. Well, the problem is, here's 3 pi over 2, but 7's never going to show up. So I'm going to count. This is 1 pi over 2. 2 pi over 2 is equal to 1 pi. 3 pi over 2. 4 pi over 2 is equal to 2 pi. Then this would become 5 pi over 2. 6 pi, 6 pi over 2, and this would be 7 pi over 2. So this right here is the ordered pair that I want to take with me. I'm going to take the ordered pair 0, negative 1, and whenever I take an ordered pair from the unit circle, I know the radius will be 1. So now I'm going to build my functions. Sine of theta is y over r, that's negative 1 over 1, which is negative 1. The cosine of theta is x over r, which is 0 over 1, which is 0. And the tangent of theta is always the y over the x, so negative 1 over 0, which is undefined. Okay. When I go to the cosecant of theta, I still am going to have negative 1, because 1 over negative 1 is still negative 1. When I go to the secant of theta, I'm going to get 1 over 0, which is that undefined. And then when I do cotangent of theta, I will get 0 over negative 1, which equals 0. You'll notice that whenever I get 0, its partner is undefined, or when I get undefined, its partner is 0. That's it. With these ordered pairs, it's much, much easier to work. When we go to 21, it asks us to draw the angle and make a reference angle. Talk about what the reference angle is. First thing I want to do is try to draw 8 pi thirds. Well, it may not be all that simple. So what I'm going to do is, first thing, I'm going to try to do it here. I've got, I'll change colors, got 1 pi thirds, 2 pi thirds, 3 pi thirds, because 3 over 3 is 1. 4 pi thirds, 5 pi thirds, 6 pi thirds, 7 pi thirds, 8 pi thirds. So I'm going to go around and back to here. So starting here, around and back to this angle. That's my goal. But let's go ahead and do that now. I'm going to go around and back to about here. Okay? And so there's my angle. But I'd like to talk about its reference angle. In other words, if I made a right triangle out of that, what would its theta be? So here's one side, here's another side, and of course theta goes right there. So what's that theta? Well, the 360 isn't going to help me. So I want to talk about, going back to that unit circle, as I went around, 2 pi was 6 pi over 3. So I don't care about that. I want to know how many more pi thirds did I use. Well, to get from 6 to 8, I had to use 2 pi thirds. That makes sense. How many pi thirds would it take to get down to pi? Well, I would need 3 pi thirds, so I'm missing 1. So I know that this angle, theta, is actually pi over 3. Now, if that's something you're struggling with, wow, how does he do that? How's Mr. Welch so smart? You can always change this to degrees. 8 pi thirds, I would multiply, by 180 over pi. The pi's would cancel, and I would get 480 degrees. That means I'd go around 360. That'd be here, 360. And then this piece right here would have had to be 120. Well, how many degrees is left to get to 180? This would have to be 60. Now, if you look at your unit circle, let's see if pi thirds and 60 degrees are really the same thing. 60 degrees, pi thirds. That is the amount of angle that I have left over from here. So this would be pi thirds, or 60 degrees. All right, so let's just real quickly get rid of all that stuff. And we're going to go back and finish the last one. Number 27 says to take the cosecant of negative 420 degrees. Well, I'm going to need some values from here. So first thing is I'm going backwards this way. And when I make one rotation, that's a negative 360. Well, if I take that 360 away from the negative 420, so I'm just going to add 360 to get what's left over, I have to have negative 60 degrees. So after the first rotation, I still need to go another 60 degrees. Well, 360 to 330 is 30 degrees, then 45 degrees, and there's the 60 degree gap. So I'm going to come all the way down to right here, and this line is where my angle is going to be at. So this is the ordered pair that I want. Okay. Another way to do this would have been to take the original negative 420, add 360, that would have given you negative 60, and add 360 again. This is that coterminal idea that if we keep adding 360, we get coterminal lines, lines that end up in the same place. This would have given me 300 degrees, and what do you know? 300 degrees puts me right where I want to be. That's the reason we did coterminal in the first place. So this is cosecant for that, and I forgot to grab the ordered pair. It's 1/2 a negative root 3 over 2. So 1/2 negative root 3 over 2. And anytime I take something from that circle, the radius is 1. This is asking me for the cosecant. I know the cosecant of theta is always the radius over the y. So that would be 1 over negative root 3 over 2. Problem is I can't divide by a fraction. So instead, I'm going to say this is equal to 1 times a negative 2 over root 3, which is just negative 2 over root 3, which I know I need to simplify to negative 2 root 3 over 3. And that is the cosecant of a negative 420 degree angle, or anything else that is coterminal with this line. If it lands here, that is the cosecant of that angle every time. I hope that helps. Just come on Monday and Tuesday and get as much help as you can. I hope it works out well for you, and we'll see you in class.